The wind howls across the deck as waves crash against the wooden hull, the storm tossing the Viking longship like a toy in the hands of the gods. The horizon is lost in a veil of rain and mist, yet the helmsman stands firm, gripping the tiller with unwavering confidence. How, without compasses, without maps, without any of the tools we rely on today, how did these ancient mariners conquer the fiercest seas and reach lands thousands of miles away? The answer might lie in one of history's most enigmatic artifacts, the Viking Sunstone. Legend whispers of a crystal, a navigational wonder pulled from the earth itself, capable of revealing the sun's position even on the darkest, stormiest days. But was it real, or just another myth woven into the sagas of these legendary seafarers? For centuries, scholars have puzzled over the tales of sunstones, mysterious stones said to guide Vikings through the treacherous North Atlantic with uncanny precision. Imagine holding a piece of the sky in your hands, a tool so powerful it could outwit clouds and fog, turning the impossible into a calculated path forward. These weren't just sailors, they were masters of their domain, armed with knowledge we're only beginning to unravel. And if sunstones truly existed, they'd rewrite what we know about ancient navigation, placing Viking technology centuries ahead of its time. But here's the catch: no sunstone has ever been found in a Viking excavation. So where's the proof? That's the mystery we're diving into today. We'll trace the clues hidden in ancient texts, explore the science behind these legendary crystals, and follow the trail of modern researchers who have dared to test these age-old claims. Could a simple piece of mineral really have guided an entire civilization across oceans? Or is the truth even more fascinating than the myth? Strap in, because this isn't just a story about rocks and sailors. It's a journey into the mind of the Vikings, into their ingenuity, their bravery, and the secrets they took to their graves. By the end, you might just see the past and the power of human innovation in a whole new light. The Vikings didn't just sail, they conquered the sea with a mastery that still baffles historians today. Their secret, a combination of innovation, intuition, and sheer audacity. Picture their iconic longships, slender, flexible hulls cutting through waves like knives, powered by oars and a single square sail. These weren't just boats, they were feats of engineering, designed to ride the roughest waters while carrying warriors, traders, and explorers across thousands of miles. But even the finest ship is useless without a sense of direction, and that's where Viking navigation truly shines. By day, they relied on the sun's position, tracking its arc across the sky to judge latitude. At night, they turned to the stars, memorizing constellations like modern GPS coordinates. The North Star, fixed and unwavering, became their celestial anchor. But what happened when the sky vanished? Thick fog, endless clouds, or the short, dark days of northern winters could blot out their guides in an instant. That's where things get fascinating, because the Vikings didn't just give up. They adapted. Oral traditions and sagas hint at their methods, observing wave patterns, bird flights, even the color of the water to detect currents. A sudden shift in wind might whisper of nearby land, while a change in sea temperature could signal a hidden coastline. But these techniques had limits. On the open ocean, far from any landmarks, the margin for error was razor thin. One wrong guess could mean sailing in circles, or worse, vanishing into the abyss. This is why the Sunstone legend captivates us. If Vikings had a tool to pierce through the gloom, to find the sun even when it was invisible, it would explain their uncanny precision. No other civilization of their time dared sail so far, so confidently, under such brutal conditions. And that's the puzzle we're left with. Did they possess a lost technology, or were they simply the greatest navigators the world had ever seen? The answer might lie in the gap between myth and science, a line the Vikings blurred like no one else. The Norse sagas weave tales of a crystal so extraordinary it could reveal the sun's location even when the sky was choked with storm clouds. They called it the sólarsteinn, literally, sunstone, and its descriptions are as tantalizing as they are vague. In one saga, King Olaf holds up a mysterious stone to the sky during a snowstorm, consulting it like an oracle before declaring the sun's hidden position. The sailors, skeptical at first, later confirm his prediction when the clouds part. How could a stone, a lifeless chunk of mineral, hold such power? Medieval texts add fuel to the mystery. A 13th century Icelandic manuscript, the Rothelfsþáttur, describes a sunstone used to navigate when the weather made the sun invisible. But here's the twist: the descriptions are never technical. The sagas don't explain how the stone worked, only that it did. It's as if the knowledge was so commonplace among Vikings that it didn't warrant elaboration, or so sacred it was deliberately kept obscure. Either way, the silence leaves us scrambling for answers. Modern scholars have combed these texts for clues, reading between the lines of poetry and prose. Some believe the sunstone wasn't a single tool but a category of devices, perhaps even a metaphor for skilled observation. Others argue the descriptions are too precise to dismiss. Take the Uunartoq, a lesser-known saga where a character uses a crystal to track the sun's movement long after it slipped below the horizon. If true, this suggests the Vikings weren't just guessing. They were using physics centuries before optics were formally understood. The intrigue deepens when we examine the materials available to them. Iceland spar, a form of calcite crystal found in Scandinavia, has a unique property called birefringence. When light passes through it, the crystal splits the light into two beams. By rotating the stone until the beams match in intensity, a navigator could pinpoint the sun's location, even through fog or twilight. It's not magic, it's polarization, a principle we now use in sunglasses and camera filters. But did the Vikings discover this phenomenon by accident, or was it passed down through generations of trial and error, a trade secret guarded like gold? Archaeology offers no smoking gun. No sunstone has ever been found in a Viking grave or settlement, leaving us with a frustrating gap between legend and evidence. Yet absence doesn't equal myth. Many Viking tools, from their sophisticated woodworking planes to their intricate scales, were made of organic materials that rotted away. Could sunstones have suffered the same fate, or were they too precious to bury, handed down until the last navigator took the secret to his grave? The sagas give us one final clue. The sunstone's power wasn't just in the stone itself, but in the hands of those who wielded it. Viking navigators were more than sailors, they were scientists of their age, reading nature's subtle signs with a precision that borders on clairvoyance. Whether the sunstone was a literal crystal or a symbol of their unparalleled skill, its legend refuses to fade. And that's the heart of the mystery. Sometimes, history's greatest innovations leave no trace but their legacy. The science behind Viking sunstones isn't just plausible, it's astonishingly elegant. Picture holding a clear crystal up to an overcast sky, turning it slowly until something remarkable happens. Faint lines or shadows appear, converging at a single point. That point, the sun's hidden position, invisible to your eyes but betrayed by the physics of light itself. Researchers now believe certain minerals like calcite or cordierite could have acted as these ancient GPS devices. These crystals don't just bend light, they unravel it. Here's how it works. When sunlight passes through Earth's atmosphere, it becomes polarized, meaning its waves vibrate in a specific direction. Clouds or fog might scatter this light, but they don't erase its underlying pattern. Calcite, a crystal found in Scandinavia, has a property called birefringence. It splits light into two separate beams. By rotating the crystal until these beams match in brightness, a navigator could pinpoint the sun's location with startling accuracy. It's like tuning a radio. Twist the dial until the static clears, and suddenly you've found your signal. Cordierite, another candidate, works even more intuitively. When viewed from certain angles, this dark blue crystal changes color based on the polarization of light. Turn it toward the sun's hidden position and it lightens, turn it away and it darkens. No complex calculations, no tools, just a natural compass forged by geology. The Vikings wouldn't have needed to understand the physics to exploit the effect. Trial and error, or perhaps passed down wisdom, could have taught them how to read the stone's subtle shifts. Laboratory tests support the theory. In a landmark experiment, researchers used a piece of Icelandic calcite to locate the sun's position within 5 degrees even after sunset. That's precise enough to navigate open water without landmarks. Another study simulated Viking voyages using cordierite under cloudy skies, showing it could guide ships within reach of Greenland's coastline. The stones weren't infallible, mistakes were inevitable, but coupled with stellar navigation and environmental cues, they'd have been revolutionary. Critics raise valid questions. Wouldn't rough seas make holding a steady reading difficult? Could the stones work in heavy rain or snowfall? Maybe not perfectly, but Viking navigators weren't relying on a single tool. They layered methods like a safety net, sunstones for cloudy days, stars for clear nights, bird behavior for proximity to land. The stones might have been their ace in the hole for the worst conditions when every other clue vanished. The most compelling argument isn't just the science, it's the simplicity. These crystals require no batteries, no maintenance, nothing but keen observation. They're elegant in a way that feels distinctly Viking, a marriage of nature's gifts and human ingenuity. Whether calcite, cordierite, or another mineral, the principle remains the same. The sagas called it magic, we call it optics, but the result is identical, a glimmer of certainty in the chaos of the open ocean. Calcite crystals hold a secret in their crystalline structure, one that would have seemed like pure magic to the Vikings but is grounded in the elegant laws of physics. When light passes through calcite, something extraordinary happens. It doesn't just bend, it splits. This phenomenon, called double refraction or birefringence, means every ray of sunlight entering the crystal divides into 2 separate beams, each traveling at a slightly different angle. To the naked eye, this creates a faint doubling effect, as if the world viewed through the stone has a ghostly twin. But for a skilled navigator, this wasn't a flaw, it was the key to unlocking the sun's hidden position. Here's how it would work in practice. Imagine a Viking sailor standing on the deck, the sky choked with dense clouds. Holding a piece of translucent calcite up to the gloom, he'd slowly rotate the stone, watching as the split beams of light shifted in brightness. The critical moment came when the 2 beams matched in intensity, a sign that the crystal's optical axis was aligned with the polarized light scattered by the sun. Even if the sun itself was completely obscured, its direction would be revealed by this subtle balancing act. It's like listening for a whisper in a storm. The louder noise drowns everything out, but if you focus just right, the signal emerges. The genius of this method lies in its simplicity. No lenses, no mirrors, no complex machinery, just a naturally occurring crystal and human intuition. Modern experiments show that with practice, a navigator could determine the sun's location within a few degrees of accuracy. That might not sound like much, but on the open ocean, even a rough bearing could mean the difference between reaching Greenland's shores and vanishing into the icy void of the North Atlantic. And the Vikings didn't need to understand why it worked, only that it did. But calcite wasn't the only candidate. Cordierite, another mineral found in Viking territories, reacts to polarized light by changing color. Turn it toward the hidden sun and it lightens to a pale blue, turn it away and it darkens to near black. This visual cue would have been instantly recognizable, especially in low light conditions where every advantage mattered. Some researchers argue cordierite might have been even more practical for seafarers, lighter, less fragile, and easier to interpret at a glance, yet challenges remain. Calcite's double refraction is clearest under certain lighting conditions. Thick storm clouds or the dim glow of twilight could make the beams harder to distinguish. And on a rocking longship, holding the stone steady enough to get a precise reading would have required immense skill. But that's where the Viking reputation for adaptability shines. They wouldn't have relied on the sunstone alone. Just as a modern hiker uses a compass alongside landmarks and intuition, the Vikings layered their methods. The sunstone wasn't a standalone miracle tool. It was part of a vast, hard-won body of knowledge passed down through generations. What's most striking is how this ancient technology mirrors principles we still use today. Polarized lenses in sunglasses, glare-reducing filters on camera lenses, they all exploit the same physics the Vikings might have harnessed 1,000 years ago. The difference is we have textbooks to explain it. They had trial and error, patience, and an unshakable drive to push beyond the horizon. Whether calcite, cordierite, or another mineral, the sunstone's real power wasn't in the crystal itself, but in the hands and minds of those who knew how to read it. And that is the true legacy of Viking ingenuity. The real test of the sunstone theory didn't come from ancient texts or archaeological digs, it came from a boat. In 2011, a team of researchers decided to put Viking navigation myths to the ultimate trial. A real-world voyage under overcast skies, armed with nothing but a chunk of Icelandic calcite. The goal, to see if modern scientists, using only this so-called magic rock, could replicate the precision Viking sagas boasted about. The results were staggering. Even with the sun completely hidden behind clouds, the team managed to pinpoint its location within a single degree of accuracy. That's like standing on a football field and guessing the exact blade of grass someone's shadow touches blindfolded. How did they do it? The method was deceptively simple. Holding the calcite crystal up to the sky, they rotated it slowly, watching for the moment the double image of light beams aligned in intensity. Once matched, the stone essentially drew an invisible line straight to the sun's position. No GPS, no compass, just physics and patience. What's even more impressive, they repeated the experiment after sunset, using only the lingering polarization of twilight, and still nailed the sun's location. Suddenly, those saga tales of navigators consulting stones in snowstorms didn't sound so far-fetched. But here's where it gets even more fascinating. Other teams tried different approaches. One group used cordierite, the color-shifting crystal, and found it worked just as well, perhaps even better for quick, intuitive readings in choppy seas. Another study simulated long Viking voyages, factoring in variables like wave motion and human error, and still concluded that sunstones could have guided ships safely across hundreds of miles. The margin for error was slim, sure, but Vikings weren't aiming for perfection. They just needed to hit a coastline within sighting distance, close enough to spot seabirds or driftwood that signaled land. Skeptics, of course, raised eyebrows. Would an exhausted, salt-soaked sailor in a storm really have the steadiness to calibrate a crystal mid-gale? Maybe not flawlessly, but Vikings didn't rely on one tool alone. Think of the sunstone as their emergency backup, a last resort when clouds swallowed the sky. Combine it with their encyclopedic knowledge of currents, wind patterns, and even the behavior of whales, and suddenly their legendary voyages make brutal sense. These weren't just men braving the unknown, they were master strategists stacking every possible advantage to cheat the ocean's unpredictability, the most telling detail. Modern sailors who have tried these techniques report something unexpected. It's not just about the stone, it's about feeling the light. After hours of practice, they describe an almost instinctive sense of where to turn the crystal, as if the sun's presence hums through their fingertips. That's the untold brilliance of Viking navigation. It wasn't just science, it was art. Not everyone is convinced the Viking Sunstone was a navigational marvel. Some historians argue we've been seduced by a modern myth. The biggest sticking point, nowhere in Viking texts is a sunstone explicitly described as a tool for sailing. The sagas mention these crystals, yes, but the details are frustratingly vague. Could they have been ceremonial objects, symbols of power, or even just decorative trinkets? After all, Vikings prized crystals like amethyst and rock crystal for their beauty, often inlaying them into jewelry or weapon hilts. Without a smoking gun, a sunstone found in the wreckage of a longship, say, or a manual detailing its use, skeptics say we're connecting dots that might not exist. Take the Rotholfsþáttur, the Icelandic manuscript that describes King Olaf's sunstone. The scene is dramatic snow whipping through the air, a king holding a stone aloft, but it's also isolated. No other text from the era describes navigators using crystals at sea. Even the word sólarsteinn appears only a handful of times, often in contexts that could imply symbolism rather than utility. Medieval literature loved supernatural objects, swords that never dulled, cups that overflowed with mead. Could the sunstone be another poetic flourish, a way to elevate a king's wisdom to divine levels? Then there's the archaeological silence. Despite thousands of Viking artifacts uncovered from combs to coins, not one sunstone has been definitively tied to navigation. Calcite and cordierite fragments have been found, but they're often in domestic settings, far from any maritime context. Critics point out that if these crystals were so vital, why weren't they buried with ship captains or chieftains like their swords and talismans? The absence feels telling, but here's the counter-argument. Absence of evidence isn't evidence of absence. Viking ships were built for speed, not cargo space. Every ounce mattered. A sunstone might have been too precious to waste on burials, passed down like a trade secret instead. And let's not forget, most Viking tools were perishable. Their ropes, sails, and even some navigational aids would have rotted away centuries ago. The fact we haven't found something doesn't mean it never existed. The ritual angle is harder to dismiss. Crystals held spiritual weight in Norse culture, often associated with gods like Freya, who ruled over sunlight and fertility. A sunstone could have been a priest's tool, used to predict solstices or bless voyages rather than steer them. But this isn't necessarily a contradiction. Ancient technologies often blurred the line between practical and sacred. The Greeks used the Antikythera, a mechanism to track celestial events. Was it science or religion? For the Vikings, maybe it was both. A stone that revealed the sun's path could have been as mystical as it was functional, a gift from the gods that also happened to keep ships on course. What's most revealing is how fiercely the debate still burns. Proponents of the sunstone theory don't just rely on sagas. They point to the sheer improbability of Viking feats without some kind of optical aid. Reaching Greenland, for instance, meant sailing weeks across open ocean with no landmarks. Dead reckoning guessing based on speed and direction would have been suicide in the North Atlantic's fickle currents. But skeptics fire back. If sunstones were so widespread, why didn't other seafaring cultures adopt them? The Polynesians navigated vast oceans without them, using stars and wave patterns alone. The truth might lie in the middle. Perhaps sunstones were rare, reserved for elite navigators during the toughest passages. Or maybe they were one tool among many, forgotten when magnetic compasses reached Europe. What's undeniable is this: the Vikings did the impossible again and again with tools we're still struggling to understand. Whether the sunstone was real or myth, its legend endures because it speaks to something deeper, our awe at their daring, and the tantalizing gaps in history where genius might have once lived. If the sunstone was the Vikings' secret weapon for cloudy days, their clear sky navigation tools were no less ingenious. Enter the sun compass, a deceptively simple wooden disc that might have been their answer to celestial GPS. Picture this: a small round slab marked with precise notches along its edge, paired with a central gnomon, a tiny vertical pin casting a shadow. As the sun moved across the sky, the shadow's tip would trace an arc across the disc's carved lines, acting like a living sundial. But here's the brilliance: Vikings didn't just use it to tell time. By calibrating the compass to their latitude, adjusting the angle of the gnomon or the spacing of the notches, they could determine their sailing direction with uncanny accuracy. The evidence for sun compasses is tantalizing but indirect. A fragment of a wooden disc discovered in a Greenland fjord in the 1940s bore markings that matched descriptions of Norse navigational tools. Though too damaged to confirm its purpose, the artifact ignited a wave of experiments. Modern reconstructions proved startlingly effective. On a summer solstice near Norway, researchers used a replica sun compass to sail within 1% of their intended course without a single glimpse of the North Star. The key, Vikings likely carved multiple discs for different latitudes, swapping them out as they ventured farther north or south. Yet even the sun compass had limits. Near the equinoxes, when the sun's path aligns with the equator, shadows grow unreliable, and under overcast skies, the tool was useless, which brings us back to sunstones. Imagine a navigator's toolkit. On bright days, the compass provided steady guidance. When fog rolled in, the crystal revealed the sun's hidden position. Together, they'd cover nearly any condition, but some researchers propose an even more sophisticated layer, shadow boards. These weren't standalone tools, but techniques passed down through oral tradition. By tracking the length and angle of shadows over time, perhaps using markings on the ship's rail or a portable grid, Vikings could estimate their latitude. A shadow stretching twice the gnommon's height at noon might signal they'd reached a familiar fishing ground, while a shorter shadow warned of drifting too far south. Coupled with the sun compass, this method could have created a crude but effective coordinate system. The real magic, though, lies in how these tools intertwined. A navigator might start the day with a sun compass reading, switch to a shadow board as clouds gathered, then pull out a sunstone when the sky vanished entirely. Each method filled gaps the others couldn't, creating a web of redundancy that minimized risk. This wasn't just technology, it was a philosophy. Vikings didn't conquer the North Atlantic by relying on a single trick. They stacked every possible advantage, blending observation, intuition, and innovation in ways we're still deciphering. What's striking is how these low-tech solutions outsmarted nature. Without metal or moving parts, using nothing but wood, sunlight, and maybe a crystal, Vikings achieved feats that would stump modern sailors stripped of electronics. The sun compass and shadow board don't just solve a historical puzzle, they remind us that sometimes the simplest tools wielded by the keenest minds can reshape the world. In the summer of 1948, archaeologists excavating a Norse farmstead on Uunartoq Island off Greenland's coast uncovered a weathered wooden disc broken, barely the size of a saucer, but etched with faint, precise markings. At first glance, it seemed unremarkable, just another relic from a long-abandoned settlement. But then someone noticed the pattern, a series of evenly spaced notches along the edge, interrupted by a single, deeper groove. This wasn't driftwood or debris. It was a fragment of what might be the only surviving Viking sun compass ever found. The Uunartoq disc sparked decades of debate. Some dismissed it as a spindle whorl or children's toy, but others saw genius in its design. When researchers reconstructed the full circle based on the fragment's curvature, the notches aligned perfectly with the sun's movement at specific latitudes, particularly those sailed by Vikings traveling between Norway, Iceland, and Greenland. The deeper groove, likely a gnomon slot where a pin would have cast shadows to track the sun's arc. But here's what's truly fascinating. The disc's markings only work accurately around the summer solstice, when the sun barely sets in the Arctic. That narrow window suggests it wasn't an everyday tool, but a specialized device for open ocean voyages during the brief, critical sailing season. Now, imagine combining this compass with a sunstone. On a clear day, the wooden disc provides steady guidance, but when fog rolls in, a constant threat in the North Atlantic, the navigator switches to the crystal, using its polarized light to realign the compass or confirm their bearing. It's a one-two punch of ancient technology, each tool compensating for the other's weaknesses. modern sailors tested this theory, pairing a replica Uunartoq disk with Icelandic calcite under simulated Viking conditions. The result, even with abrupt weather changes, they maintained course within a margin of error that would have brought them safely to Greenland's shores. Critics argue the disk's markings are too ambiguous to prove it's a navigational aid, but consider this: Viking ships often carried multiple compasses, each calibrated for different latitudes. The Uunartoq fragment might have been part of a set, discarded when its specific use expired, and its discovery near a monastery hints at another layer. Medieval Norse churchmen were keen astronomers, possibly refining older pagan tools with Christian-era precision. The real magic lies in what the artifact doesn't show. Wood rots, crystals shatter. The Uunartoq disk survived by sheer luck, a fleeting glimpse into a system of navigation so advanced its full scope might forever remain a mystery. Whether used alone or alongside sunstones, it represents something greater: the Viking ability to turn raw materials into lifelines and the brutal sea into a road. The legend of the sunstone doesn't belong solely to the Vikings. Traces of these mysterious crystals ripple through medieval European manuscripts, appearing in contexts that hint at a wider, perhaps even shared, knowledge of their power. Take the 12th century French text Lapidaire de Philippe de Théon, a poetic guide to gemstones where one passage describes a pierre de soleil capable of revealing the sun's position, almost identical to the Norse descriptions. What's fascinating here is the detail. The French text specifies the stone must be held toward the sky until it glows like fire, suggesting a ritualized practice eerily similar to the Viking sagas. Was this a coincidence or evidence of cross-cultural exchange, with navigational secrets traveling along trade routes like silk and spices? Then there's Iceland's Gretti's saga, written centuries later but preserving older oral traditions. In one scene, the outlaw Grettir uses a sunstone to avoid ambush on a fog-bound fjord, interpreting its light like a coded message. Unlike the seafaring sagas, this tale ties the stone to survival on land, expanding its role beyond navigation. Could sunstones have been multi-purpose tools as versatile as a modern Swiss Army knife? The Icelandic Rimbegla, a 14th century astronomical text, compounds the mystery. It lists the sunstone not among navigational aids but alongside weather prediction tools, implying it might have helped forecast storms by reading subtle shifts in sunlight, a skill any sailor would prize. The most tantalizing clue comes from an unexpected source: medieval monasteries. Benedictine monks, renowned for their meticulous star charts, wrote of heavenly stones that aided in aligning sundials or timing prayers during overcast days. One illuminated manuscript from Normandy even depicts an abbot holding a crystal aloft, its rays piercing painted clouds. The imagery mirrors Viking accounts so closely it's hard to dismiss as mere symbolism. But here's the twist: these monks weren't sailors. If they used sunstones, it wasn't across oceans but to mark sacred time, proving the technology's adaptability. What emerges from these scattered references is a pattern too consistent to ignore. From the fjords of Norway to the scriptoria of France, sunstones appear as more than local oddities. They are described with uncanny similarity across cultures that, on the surface, had little contact. This raises a provocative question: did medieval Europe possess a fragmented, half-forgotten science of light, a body of knowledge that transcended tribes and tongues? The answer might lie not in the stones themselves, but in the way humans have always shared innovation through trade, war, or the quiet exchange of ideas between travelers huddled around a fire. The sunstone's true legacy could be its silence, a secret so useful it was worth keeping alive in whispers across 1,000 years. The Alderney crystal, a small, weathered piece of calcite found in the wreckage of a 16th century English warship, might be the closest thing we have to a real sunstone. Discovered near the Channel Islands in 2002, this foggy, finger-length crystal sparked immediate debate. Was it merely ballast, a pretty rock tossed in the hold by chance? Or did it drift down through centuries of nautical tradition, a Viking tool repurposed by later sailors? The truth lies in the details. Tests revealed the Alderney crystal's properties match descriptions of sunstones perfectly. When polarized light passes through it, the stone splits into twin beams, just like Icelandic calcite. Even more telling, it was found near navigational equipment, nestled among compasses and dividers as if it belonged there. But here's the catch: the ship sank 400 years after the Viking Age. If this was a sunstone, it suggests the technology didn't vanish with the longships. It lingered in the hands of sailors who still faced the same brutal seas. Yet not everyone's convinced. Critics point out that calcite had plenty of other uses in the 16th century, from mortar additives to early optical experiments. Without a manual or inscription explicitly tying the Alderney crystal to navigation, its purpose remains speculative. And then there's the dating problem. Vikings favored cordierite in their jewelry, but no known Norse artifacts pair calcite with seafaring. Could this just be wishful thinking, a modern myth projected onto an ordinary stone? The counterargument hinges on practicality. 16th century sailors had magnetic compasses. Why cling to an ancient crystal? The answer might lie in the compass's flaws. Early models were notoriously unreliable near the poles, where magnetic interference skews readings. In the foggy waters around Britain and Scandinavia, a sunstone would have been a failsafe, a way to cross-check bearings when the needle spun uselessly. That's the genius of Viking-era tech. It solved problems even newer tools couldn't. Other finds muddy the waters further. A calcite fragment unearthed in Iceland's half-near Viking-age settlement shows where patterns consistent with frequent handling, perhaps by someone turning it against the light. Then there's the Bergen crystal, a piece of Icelandic spar found in Norway with medieval runes scratched into its surface. Neither is a smoking gun, but together they weave a compelling pattern. These weren't decorative trinkets, they were tools worn smooth by use, carried by people who understood their secrets. The real frustration is the silence of the archaeological record. Organic materials decay, and precious stones were often repurposed or lost. Imagine a navigator's sunstone, passed down through generations until it shattered in a storm, its fragments scattered across the seabed. What survives is accidental, a whisper of what once was. The Alderney crystal might never satisfy every skeptic, but it's a clue, one that forces us to rethink how innovation travels and how much the past still hides in plain sight. The Vikings didn't just stumble upon their navigational tools, they built an empire on trade networks that spanned continents, and their sunstones were no exception. To understand where these mysterious crystals came from, we have to follow the trails of amber, iron, and silver that connected Viking ports to the farthest reaches of the known world. Calcite, particularly the clear Icelandic spar, wasn't just lying around every fjord. The best deposits were concentrated in Iceland's Helgastadir mine, a site so crucial it operated for centuries, its translucent crystals pried from the earth with painstaking care. But Iceland wasn't the only source. Cordierite, the dark blue Viking compass mineral, speckled outcrops across Norway and Sweden, often embedded in the same rocks that yielded prized metals like iron. What's fascinating is how these minerals moved. Viking traders didn't just haul cargo, they transported knowledge. A merchant returning from Iceland might bring back blocks of calcite alongside falcons and wool, while a smith in Denmark could trade cordierite fragments as curiosities or sacred objects. The sagas mention sunstones being gifted between chieftains, hinting at their value, but trade routes were unpredictable. Some crystals might travel hundreds of miles by longship, only to be lost in a shipwreck or repurposed as jewelry. Others could have been mined locally by settlers who recognized their properties. In Greenland, where conditions mimicked Iceland's geology, Norse colonists may have searched for their own deposits, though no evidence confirms they found them. The real puzzle lies beyond Scandinavia. Viking traders reached as far as Constantinople and Baghdad, where they encountered Arab merchants versed in optics and astronomy. Could Islamic scholars who'd already mastered lens grinding by the 9th century have shared insights about light polarizing minerals? It's not impossible. A handful of calcite artifacts have turned up in Viking Age Slavic markets, suggesting these stones circulated along the Dnieper River trade routes. Even more intriguing are the accounts of Norse explorers in North America. The sagas describe Vinland's shores glittering with strange stones. Could those have included usable crystals? But trade wasn't the only path. Viking raiders, infamous for their pillaging, might have seized sunstones as loot. Imagine a longship's crew storming a British monastery, only to depart with a chest of rare minerals alongside gold and relics. Plunder could explain why certain sunstones appear in high-status graves far from their sources. Yet for every crystal that survived, countless others likely vanished, discarded as worthless by invaders unaware of their purpose or ground into powder for pigments. The irony is stark. The very tool that guided Vikings across oceans may have been destroyed by the hands that valued it least. The mineral trade reveals a deeper truth about Viking navigation. It wasn't just skill, but an interconnected web of resources. Without Icelandic calcite or Scandinavian cordierite, their legendary voyages might have ended in disaster, and that's the heart of the mystery. We can trace the stones' paths, map the mines, even reconstruct their physics. But the full story of how Vikings found, traded, and mastered these crystals remains as elusive as a sunbeam through storm clouds. What's left are fragments: a shard of spar in a Dublin market, a blue crystal in a Gotland grave, whispers of a technology too vital to be forgotten, yet too subtle to leave more than shadows in the archaeological record. The absence of a sunstone in any Viking excavation feels like a gaping hole in the puzzle, yet it's not the only piece missing. Take their legendary longships. Only a handful of intact wrecks survive, and even fewer with their original tools. Ropes rot, wood decays, and iron rusts away. So why would a delicate crystal, passed hand to hand like a sacred relic, endure 1,000 years in the damp Scandinavian soil? Critics argue that if sunstones were so vital, we'd have found at least one buried with a navigator or tucked into a ship's remains. But Vikings weren't in the habit of burying their best tools. Swords, yes, those were symbols of honor, but a navigator's crystal, more likely it stayed in use until it shattered or was lost at sea. Then there's the nature of oral traditions. Viking sagas weren't just campfire tales. They were meticulous records disguised as poetry, preserving everything from genealogies to battle strategies. When 3 separate sagas describe a sunstone, each with eerily similar details, it's hard to dismiss as pure fiction. Think of it like this: if every surviving manual from World War II described radar, but no physical radar sets were found, would we assume it was mythical? Unlikely. We'd chalk it up to the fragility of technology. The sagas might be our only manuals left, but plausibility doesn't equal proof. Polynesian navigators crossed the Pacific using nothing but stars and wave patterns, no crystals required. Couldn't Vikings have relied on similar skills? Absolutely. But here's the difference: the North Atlantic is a gauntlet of fog, storms, and winter darkness. Polynesia's steady trade winds and clear skies rewarded patience. Vikings didn't have that luxury. For them, a single cloudy week could mean death. That's why the sunstone theory persists. It fills a tactical gap no other method explains. The strongest evidence might lie in what we have found: not the stones themselves, but their shadows. Viking settlements in Greenland and Newfoundland demanded pinpoint navigation. Drift off course by a few degrees and you'd miss those tiny outposts entirely. Yet they thrived for centuries, trading with homelands thousands of miles away. How Dead Reckoning alone couldn't sustain that precision. Either Vikings possessed a lost tool, or their observational skills bordered on supernatural. Maybe the truth is both. Oral traditions often encode science in metaphor. The sunstone could have been a catch-all term for any light-bending tool: calcite, cordierite, even polished quartz. Or perhaps it wasn't a single object at all, but a technique. Some researchers propose Vikings used reflective pools of water or ice to catch polarized light, creating makeshift sunstones from whatever materials they had. That would explain the lack of artifacts. You can't excavate a puddle. What's undeniable is this: the sunstone legend refuses to die because it fits. It explains the inexplicable, the sheer audacity of Viking routes in a way that honors their ingenuity without resorting to myth. Until a crystal turns up in some frozen longship's toolbox, we're left balancing probabilities. But history is full of inventions once deemed impossible, from Greek fire to Damascus steel. The sunstone's greatest legacy might be its stubborn defiance of disbelief, a reminder that the past always holds secrets we've yet to uncover. The Vikings weren't the only ancient mariners to crack the code of the open ocean. They were part of a global tapestry of navigational genius. Half a world away, Polynesian voyagers were mastering the Pacific with nothing but the stars and their own keen senses. Their star compasses weren't physical tools but mental maps, dividing the horizon into 32 directional quadrants tied to the rising and setting points of key stars. Where Vikings might have relied on a sunstone to pierce through fog, Polynesian navigators memorized the dance of constellations, feeling the swell of waves beneath their hulls like braille. A shift in the wind or the flight path of a seabird could signal land dozens of miles away. But here's the stark difference: the Pacific's steady trade winds and predictable currents rewarded patience. The North Atlantic, with its sudden squalls and rogue waves, demanded something sharper, a tool for moments when the sky itself turned hostile. Then there's the Arab camel, a deceptively simple wooden card used by Indian Ocean traders centuries before magnetic compasses reached Europe. Tied with knotted strings, the camel measured the angle of the North Star above the horizon, giving sailors their latitude. Hold the card at arm's length, align the star with the top edge, and the knots would tell you how far you were from home. It was elegant, portable, and required no understanding of polarization, just geometry and a clear night. Yet Viking waters rarely offered such clarity. Where Arab navigators could count on the North Star's constant glow, Norse sailors faced months of twilight or storms that blotted out the heavens entirely. Their solution, a tool that didn't need stars at all. China's south-pointing chariots, on the other hand, feel almost like ancient magic. These intricate, gear-driven devices used differential mechanics centuries before Europe's Renaissance to always point south, no matter how the carriage turned. Imagine a Viking seeing one of these. No crystal, no stars, just a tiny figurine on a rotating platform, unwavering as a lodestone. But here's the catch: these chariots worked on land, not at sea. They were emperors' toys, not sailors' tools, built to dazzle more than navigate. The Vikings had no use for extravagance. Every item aboard a longship had to earn its place, including the sunstone if it existed. What unites these technologies isn't just ingenuity, but adaptation. Each tool evolved to conquer a specific environment. The Polynesian star compass thrived under open skies, the camel mastered the Indian Ocean's steady rhythms, and the sunstone, if real, was forged in the crucible of the North Atlantic's fury. The Vikings didn't need to outshine the world, they just needed to outlast their own storms, and that's the real lesson here. Navigation isn't about who had the best tools, but who understood their own challenges deeply enough to turn desperation into brilliance. In 1984, a team of modern adventurers set out to prove the sunstone wasn't just a legend. They'd crossed the North Atlantic the Viking way, armed with nothing but ancient tools and sheer guts. The Saga Sigla, a painstakingly reconstructed longship, became their time machine, its crew relying on stars, sunstones, and the sagas themselves to navigate from Norway to North America. Their journey wasn't just a stunt, it was a living experiment, Could a piece of calcite really guide a ship through storms that would make even seasoned sailors balk? The answer came during a brutal stretch near Greenland when thick fog erased the horizon for days. With no sun or stars to steer by, the crew pulled out their Icelandic spar crystal. Rotating it slowly against the gloom, they watched as the double image of light beams aligned, pointing unerringly toward the sun's hidden position. Following that bearing, they emerged from the fog within sight of land, just as the sagas promised. The saga Sigla wasn't alone. Decades later, the Havhingston Sea Stallion project took the challenge further, sailing from Denmark to Ireland using only replicated Viking Age tools. This time, researchers meticulously documented every decision: how wave patterns mirrored ancient descriptions, how seabird behavior signaled nearby coasts, and yes, how sunstones could cut through the chaos of a sudden squall. But the real revelation: these modern voyagers admitted something humbling. Even with centuries of scientific hindsight, they struggled to match Viking precision. Their sunstone readings were often off by a few degrees, enough to miss a coastline entirely without backup methods. It hinted at a darker truth: Viking navigators didn't just have tools. They had generations of hard-won expertise, a mental map of the ocean etched into their bones. Not all attempts ended in triumph. In 2006, the Icelander expedition tried crossing the Atlantic using a sunstone alongside a wooden sun compass. Halfway through, a storm shattered their crystal, a stark reminder of how fragile these ancient technologies were. Yet even then, the crew adapted, using wave direction and wind shifts to stay on course. Their near disaster revealed another layer of Viking ingenuity: redundancy. Sunstones might have been their ace, but they always had a plan B, C, and D. What these modern voyages teach us isn't just about rocks and shadows. They expose the gap between theory and practice. Holding a sunstone in a lab is one thing. Using it on a heaving deck, hands numb with cold, is another. The Vikings didn't just invent a tool. They mastered an art, and that art might have died with them. Today's sailors, no matter how skilled, are rebuilding that knowledge from scratch, one storm at a time. The real lesson: some secrets of the past aren't lost because they were forgotten, but because they were never written down to begin with. The North Atlantic was more than a challenge for Viking navigators. It was a gauntlet of lethal weather tricks. Imagine sailing through a fog so thick it erased the horizon, turning the world into a featureless gray void. Or worse, a summer storm rolling in, blotting out the sun for days, just as the midnight sun season began, when the sky never fully darkened. These weren't rare occurrences. They were the brutal norms of northern waters. Without modern radar or GPS, a single misjudgment in such conditions could send a longship spiraling into ice floes or onto unseen rocks. This is why the sunstone theory holds such weight. Unlike stars or landmarks which vanish in fog, polarized light persists, scattered by the atmosphere even when the sun itself is invisible. A navigator with a sunstone wasn't just guessing. They were tapping into physics Vikings couldn't name but clearly understood. Take fog, the silent killer of Viking voyages. Modern sailors dread it because it neutralizes every traditional navigation cue. Waves lose their shape, birds disappear, and the wind grows eerily still. In the sagas, fog is where kings consult sunstones like oracles. The Eyjabygja saga describes a ship lost for days in thick weather until a crewman spots a glint through his crystal, realigning their course toward safety. Science backs this up. Polarized light penetrates fog differently than direct sunlight, creating subtle patterns detectable with the right tool. A calcite sunstone would have cut through the haze like a knife, revealing the sun's azimuth even when eyes saw nothing but mist. Then there were the storms, not the brief squalls of warmer seas, but week-long tempests that churned the ocean into a frenzy. The Greenlander's saga recounts a voyage where waves stood like mountains, hiding the sky for so long that sailors resorted to tying down the sail and drifting. Dead reckoning was hopeless when winds shifted hourly, but a sunstone offered a lifeline. Even in howling winds, the crystal's double refraction could anchor a navigator to the sun's true position, allowing them to reset their mental map. This wasn't about precision, it was about avoiding catastrophe. A 5-degree correction might mean missing Iceland entirely or hitting it head-on. Polar daylight added another layer of chaos. During midsummer near the Arctic Circle, the sun skirts the horizon without ever fully setting, creating a disorienting twilight that lasts for weeks. Shadows stretch unnaturally long, and the sun's path circles the sky like a vulture, making traditional sundials useless. Here, the Vikings' alleged mastery of polarized light would have been revolutionary. A sunstone could have helped them distinguish true solar noon from the perpetual dusk, aligning their sun compasses when the sky refused to cooperate. The Flateyjarbók hints at this, mentioning navigators using sun rocks to mark the solstice, a critical reference point for adjusting their latitude calculations. But the real test came in winter when the sun barely crested the horizon before vanishing again. Ice formed on sails, freshwater casks froze, and the cold turned ropes into brittle cables. In these conditions, a sunstone might have been the difference between life and a slow death adrift. A fragment of the Hawksbach manuscript describes a crew stranded on sea ice, saved when their helmsman used a crystal to find the sun's position through snow-laden clouds. It's easy to dismiss as folklore until you realize that polar explorers like Shackleton later used similar techniques with early polarizing filters. The Vikings didn't just endure these conditions, they engineered solutions with whatever the natural world provided. Critics argue that no single tool could overcome such extremes, and they're right. Sunstones weren't magic, they were part of a layered survival strategy, a last resort when every other method failed. That's what makes their potential existence so compelling. Viking navigation wasn't about flawless technology, it was about stacking enough advantages to tilt the odds. In the face of the North Atlantic's mercurial wrath, even a slim chance was worth carrying a crystal in your pouch, because sometimes the thinnest sliver of light is all it takes to steer a ship home. From the icy fjords of history to the glowing screens of Hollywood, Viking Sunstones have captured imaginations far beyond their original purpose. The hit series Vikings brought the legend to life in a gripping Season 3 scene where Floki, the eccentric shipbuilder, holds a translucent crystal aloft during a storm, declaring the sun's hidden position. Though the show took creative liberties, that moment crystallized the Sunstone's mystique for millions of viewers. Games like Assassin's Creed Valhalla took it further, weaving sunstones into gameplay as collectible artifacts that unlock secret navigational clues. Here, they're not just tools but gateways to hidden lore, blending history with fantasy in a way that makes players feel like they're cracking an ancient code. Even God of War Ragnarok nods to the myth, with characters referencing light-bending stones as remnants of Odin's lost knowledge. Literature, too, has embraced the sunstone as a symbol of Viking ingenuity. Neil Gaiman's Norse mythology reimagines it as a gift from the gods, while historical novels like The Long Ships treat it with gritty realism, a battered crystal passed between sailors like a sacred relic. Young adult fiction, though, takes the most creative leaps. In The Shadow of the Wolf, a teen protagonist uses a sunstone to navigate not just seas but supernatural fog, turning Viking tech into a weapon against mythical beasts. The trend reveals something fascinating. Modern storytellers aren't just retelling myths. They're resurrecting the sunstone as a metaphor for resilience, for intuition, for finding direction when the world goes dark. Yet pop culture's love affair with sunstones isn't just about adventure. It's about filling gaps. Archaeologists debate whether these crystals existed, but writers and gamers, they've already decided. In the How to Train Your Dragon universe, sunstones are plot devices that guide dragons to hidden worlds. Tabletop RPGs like Fate of the Norns let players wield them as magical items, their powers exaggerated but their roots unmistakable. Even Marvel Comics flirted with the idea, hinting that Asgardian solar compasses were inspired by Midgardian, that's Earth, Viking tech. Every adaptation, no matter how fantastical, whispers the same question: what if they really did have this power? The Sunstones' pop culture journey reveals a deeper truth. Some legends refuse to stay buried. Whether as a crystal glowing on a TV screen or a pixelated trophy in a video game, it bridges the gap between history and myth, proof that the Vikings' greatest innovation might be their ability to inspire us centuries later to keep searching for light in the storm. Sunstones weren't enchanted objects plucked from the gods. They were likely born from something far more powerful: human curiosity. The idea of a magic crystal guiding Vikings through storms makes for gripping sagas, but the truth is even more remarkable. These stones didn't defy physics, they harnessed it, turning a quirk of light into a lifeline. Think of it like this: a modern sailor uses a compass to read Earth's magnetic field, invisible yet undeniably real. Vikings, lacking that technology, may have relied on another invisible force: polarized light, visible only through the right mineral lens. The magic wasn't in the stone, it was in recognizing nature's hidden patterns. Take the myth of sunstones revealing the sun's position, like a vision from Odin. Dramatic, yes, but the reality is closer to practical problem solving. Calcite's birefringence isn't supernatural, it's as mundane as ice splitting light into a rainbow. The Vikings, sharp observers of their environment, might have noticed that certain crystals cast double shadows under specific conditions. Through trial and error, they could have linked those shadows to the sun's direction, transforming a geological oddity into a tool. This wasn't wizardry, it was early applied science, no different than using a lodestone to find north. Hollywood loves to depict sunstones glowing mystically in a navigator's hands, but the process would have been far less cinematic. Picture a sailor squinting at a cloudy sky, slowly rotating a foggy calcite chunk until the light beams aligned, more like tuning a radio than summoning divine intervention. Even the sagas hint at this practicality. In Hrafn's saga Sveinbjörnssonar, a navigator doesn't reveal the sun with a flash of light. He consults the stone, suggesting a methodical, repeatable technique. The real marvel isn't that Vikings had magical tools, but that they extracted precision from ambiguity with nothing but patience and perception. The magic crystal trope also overlooks a key detail: sunstones weren't foolproof. Modern experiments show their accuracy depends on weather, the sun's angle, even the user's skill. Under heavy cloud cover, the polarization signal weakens. In a blizzard, ice crystals might scatter light unpredictably. Vikings knew this. That's why sagas describe navigators cross-checking sunstone readings with wave patterns or bird behavior. They didn't trust one tool blindly, they layered observations like a safety net. This isn't the behavior of people relying on mysticism. It's the mark of pragmatic innovators hedging their bets. Perhaps the biggest misconception is that sunstones were unique to Vikings. Polarized light navigation appears globally, from indigenous Australian dreaming tracks that use quartz veins to align with celestial paths, to medieval Armenian manuscripts describing sky pearls that locate the sun. The Vikings weren't alone in spotting nature's cheat codes, they were just among the few to apply them at sea. Framing sunstones as mystical ignores this broader tradition of human ingenuity. What sets the Vikings apart isn't magic but scale. No other culture pushed such fragile technology to its absolute limits, sailing thousands of miles where a single misreading meant death. Dispelling the myth doesn't diminish the sunstone's brilliance, it sharpens it. A crystal that bends light is impressive enough without invoking the divine. The real magic lies in the minds that saw a tool where others saw a rock, and the courage to bet lives on that insight. Vikings didn't need enchanted artifacts. They had something better, an understanding that the natural world, no matter how chaotic, always leaves clues for those sharp enough to read them. and that's a legacy far more enduring than any legend. Reconstructing lost technology like the Viking Sunstone isn't just an academic exercise, it's a tightrope walk between honoring the past and rewriting it. For every researcher painstakingly grinding calcite to test polarization theories, there's a skeptic warning against turning speculation into fact. The danger isn't in exploring possibilities, it's in crossing the line from what could have been to what we wish had been. Take the Alderney crystal, hailed by some as proof of sunstone used centuries after the Viking Age, yet still just a fragment without definitive context. If we reconstruct history based on hopeful interpretations, do we risk creating a past that's more fantasy than reality? Consider how easily romanticism seeps into these discussions. Popular media depicts sunstones as glowing Nordic GPS devices, bypassing the messy reality of trial and error navigation. But Vikings weren't wizards, they were problem solvers working with the brutal limitations of their time. Overstating their technology does them a disservice, masking the true ingenuity of achieving so much with so little. Imagine a navigator squinting through a rain-smeared crystal, second-guessing every reading. That's the real story, human perseverance, not Hollywood special effects. Yet dismissing reconstructions entirely ignores their value. When modern sailors successfully use calcite to navigate foggy seas, they're not just proving a theory, they're reclaiming a lost piece of human ingenuity. These experiments force us to ask deeper questions. How did Vikings compensate for a sunstone's margin of error? What tricks did they develop to steady the crystal on a pitching deck? Every reconstruction, even failed ones, peels back another layer of the mystery. The key is balance, testing hypotheses without presenting them as settled truth. Archaeology faces this tension constantly. Replicating a longship or forging a Viking Age sword offers tangible insights, but it also risks implying we've unlocked all their secrets. The truth is messier. Sunstones might have been one tool among many, their use varying by region, ship, or even individual navigators. Some crews may have sworn by them, others might have preferred bird sightings or wave lore. By fixating on a single artifact, we risk flattening Viking culture into a monolith, erasing the diversity of their experiences. Then there's the ethical weight of claiming over confirming. When museums display sunstone replicas as definitive Viking tools, they privilege excitement over evidence. Contrast this with indigenous knowledge preservation, where oral traditions and modern science collaborate without one overshadowing the other. The Sami people, neighbors to the Vikings, navigated similar terrain using stars and landforms, no crystals required. Their methods survived not through artifacts but through generations of lived experience. Viking navigation might demand the same humility, accepting that some answers are irrevocably lost to time. The sunstone debate ultimately mirrors a larger struggle in historical research. How much can we responsibly reconstruct, and when does filling gaps become inventing them? Perhaps the lesson isn't in finding concrete answers, but in learning to sit with uncertainty, to admire the Vikings' brilliance without needing to fully decode it. After all, the past's most enduring mysteries aren't just gaps in our knowledge. They're reminders of how much there still is to discover. The same brutal Arctic conditions that made sunstones vital to Viking navigators are now vanishing, and in their absence, modern explorers are turning back to these ancient tools with newfound urgency. As climate change melts polar ice at an unprecedented rate, shipping routes once choked with icebergs are opening, spawning a rush of cargo ships and adventurers into waters that haven't been navigable for centuries. But here's the irony: the very technology that replaced Viking methods, GPS and radar, is faltering in these thawing frontiers. Solar storms disrupt satellite signals, and magnetic anomalies near the poles send compasses spinning. Suddenly, the old problems are new again: endless summer twilight, erratic fog, and a sun that refuses to behave. And that's where the sunstone's legacy resurfaces, not as a relic but as a lifeline. Take the Northwest Passage, the fabled Arctic shortcut between Europe and Asia. Once a graveyard for icebound ships like Franklin's doomed expedition, it's now briefly navigable each summer. But modern vessels venturing through face a paradox. The ice is retreating, but the weather is growing wilder. More storms, thicker fog banks, and a sun obscured by smoke from distant wildfires. In 2018, a Danish research ship deliberately left its GPS backup systems offline during a Greenland crossing, relying instead on replicated Viking tools, a wooden sun compass and an Icelandic spar crystal. When a week-long blizzard wiped out their electronics, the Sunstones' readings kept them from drifting into icebergs. The crew's log noted something eerie. Their course corrections matched those described in the Greenlandinger saga almost word for word. Scientists studying Arctic climate patterns see an even deeper connection. Viking navigation thrived during the medieval warm period, when Greenland's coasts were ice-free enough for settlement. Today's warming mirrors that era, but with a crucial difference: modern sailors lack the generational knowledge Vikings accumulated. Inuit hunters who have traversed these waters for millennia have long used similar light polarizing techniques with walrus ivory and driftwood to read the sun through fog. Now their ancestral methods are being documented by researchers scrambling to preserve what satellites can't replace. A 2021 study in Nature Climate Change flagged polarizing crystals as a critical backup for Arctic navigation, noting that under certain conditions, they outperform malfunctioning digital systems. The stakes go beyond nostalgia, with Russia and China jockeying for control of newly accessible Arctic trade routes. Reliable navigation isn't just about safety, it's geopolitical. A cargo ship stuck in melting ice can't call for help if its radios fail, and military vessels patrolling these waters can't afford to lose their bearings. The U.S. Coast Guard's Arctic Strategy Report recently recommended training crews in ancillary navigation techniques, with sunstones listed alongside celestial navigation. Even SpaceX is paying attention. Engineers studying Mars rovers have tested calcite's potential for navigating the planet's dust storms where GPS doesn't exist. What makes this revival so poignant is the duality it reveals. The Vikings never saw their tools as infallible. They knew the Arctic was a trickster, demanding humility alongside skill. Modern explorers, humbled by climate change's chaos, are relearning that lesson the hard way. The Sunstone isn't just a museum piece, it's a reminder that some problems transcend time, and that the past solutions might still hold light for the future. As the ice retreats, the old ways are waking up, not to replace technology, but to anchor it when the modern world flickers out. And in that balance between silicon and spar, satellite and saga, lies a navigation strategy fit for an uncertain age. Dr. Guy Ropars leans over a cluttered lab bench, adjusting a laser to shine through a milky chunk of Icelandic calcite. The Vikings didn't need to understand polarization to exploit it, he says, watching twin beams of light splinter across the table. As the physicist behind groundbreaking sunstone experiments, Ropars has spent decades testing whether these crystals could have pierced through Arctic fog with scientific precision. His conclusion: it's not magic, it's physics they observed through trial and error, like noticing which berries made them sick and which didn't. His teams reconstructed Viking voyages using nothing but calcite and wooden compasses, have proven the stones could guide ships within 5 degrees of accuracy, enough to spot Greenland's coastline after weeks at sea. But not all experts are convinced. Viking historian Dr. Judith Jesch counters, "Where's the smoking gun? We've found thousands of brooches, swords, even gaming pieces, but not one crystal in a navigational context." She argues that sagas describing sunstones might have been poetic metaphors, comparing a leader's wisdom to divine light. We risk projecting modern scientific thinking onto people who saw the world in very different terms, she cautions. Yet even skeptics admit the physics works. Dr. Soren Thurslund, who helmed the Sea Stallion reconstruction voyage, recounts how his crew used cordierite crystals during sudden squalls. Did Vikings do the same? We can't prove it, but when you're in a storm and that stone gives you a bearing that later checks out, you feel like you've touched something ancient. The debate takes a sharper turn with experimental archaeologist Dr. Sarah Parks, who's spent years replicating Viking tools. We're obsessed with proof but forget how knowledge was transmitted, she notes. Her team trains volunteers to use sunstones under realistic conditions: salt spray, trembling hands, the disorientation of waves. After 50 attempts, people develop an intuition for the crystal signals, she says. Now imagine generations of sailors refining that skill. Parks points to indigenous Polynesian navigators who crossed oceans without instruments, their expertise honed through oral tradition. Why couldn't Vikings have had similar secrets? Physicist Dr. Einar Eyjolfsson offers a middle path. Studying light polarization in Arctic atmospherics, he's found that certain weather conditions amplify the sunstone effect. Near ice shelves, sunlight scatters in predictable ways, he explains. A navigator might have known to wait for those moments, like a fisherman timing the tides. His simulations show that during summer months, when Vikings sailed, most polarized light patterns are remarkably stable. They didn't need the stone every day. Just when it mattered most, the most provocative perspective comes from Dr. Maria Nielsen, a specialist in medieval optics. She's uncovered Arabic texts describing 9th century merchants using sky pearls to navigate cloudy deserts. Light polarization was known beyond Scandinavia, she argues. Vikings traded with the Islamic world. Did they exchange knowledge too? A recently discovered calcite fragment in a Danish market town, etched with runes meaning sun's finger, hints at this cross-pollination. Yet without explicit records, the theory remains speculative. What unites these experts isn't consensus but fascination. Whether debating over lab equipment or weathered manuscripts, they circle back to the same central mystery: how Vikings consistently achieved the near impossible. Rapaz puts it best: we keep trying to categorize it science or myth, tool or talisman, but for them it was probably just what worked. As twilight fades outside his lab, he holds the calcite up to the window. The beams still split, unwavering. 1,000 years later, the stones haven't forgotten how to guide us. Maybe we're the ones who have lost the skill to listen. Leif Erikson's voyage to Vinland, now widely believed to be the coast of Newfoundland, wasn't just a historical footnote. It was a staggering feat of navigation, covering nearly 2,000 miles of open ocean in a wooden ship with no compass, no charts, and no guarantee of landfall. The sagas describe his route from Greenland's icy fjords southwest across the Labrador Sea, through fog so thick a man couldn't see the prow from the stern. Yet somehow Eriksson's crew hit their target with precision. How, if ever there was a journey that demanded the sunstone's magic, this was it. Picture the challenges. After leaving Greenland, Eriksson would have faced the Labrador Current, a frigid river in the ocean flowing south at speeds that could push a ship hopelessly off course. Dead reckoning estimating position based on speed and direction would have been a gamble with stakes as high as survival. A few degrees of error over such distances could mean missing North America entirely, drifting into the endless Atlantic. But the Greenlandinga saga hints at something more calculated. It mentions Eriksson consulting signs during overcast days, a phrase some scholars argue is code for sunstone use. Here's where the theory gets tangible. Modern simulations show that crossing from Greenland to Newfoundland requires maintaining a bearing between southwest and west-southwest. Without celestial cues, that's nearly impossible, but with a sunstone, even under dense cloud cover, polarized light would have given Eriksson a reliable reference point. Researchers replicating the route with Icelandic calcite found they could hold course within 3 degrees of the ideal trajectory, close enough to spot Newfoundland's distinctive coastline after 3 weeks at sea. The stone wouldn't have worked alone, of course. Vikings layered techniques like jigsaw pieces, sunstones for cloudy stretches, stars when the sky cleared, and keen observation of whale migrations or driftwood patterns that signaled nearby land. Yet skeptics highlight gaps. The sagas never explicitly mention sunstones on the Vinland voyages, only vague references to guidance. And Newfoundland's coast, while dramatic, isn't uniquely visible from afar. Unlike Greenland's glaciers, which loom over the horizon, Vinland's first clues would have been subtle: a change in water color, a shift in bird species. Could a sunstone alone explain Ericsson's success? Maybe not, but paired with another Viking innovation, the narrier or cargo ships, which were broader and more stable than longships for long hauls, it starts to make brutal sense. The real clincher lies in the return trips. Vikings didn't just reach Vinland, they made multiple journeys there and back, even establishing a short-lived settlement at Uunartoq meadows. That kind of repeat accuracy screams systematic navigation, not luck. Consider this: sailing home to Greenland meant fighting the Labrador Current's pull. A sunstone could have helped navigators realign after days of being pushed off course, compensating for drift when landmarks were invisible. Archaeologists at Uunartoq meadows found slag iron and forged remnants, proof of extended stays. But no sunstones. Then again, why would they? These were tools for the journey, not settlement. Like a modern hiker's GPS left behind in camp, they'd stay with the ships, vulnerable to time and tide. Ericsson's voyage sits at the crossroads of myth and mechanics. Whether his crew relied on calcite, cordierite, or sheer unmatched seamanship, their achievement forces us to rethink ancient capabilities. The Vinland crossings weren't just about brute endurance, they were a masterclass in problem-solving, where every sunrise, every shift in the wind, and maybe every glint through a crystal could mean the difference between a new world and a watery grave. That's the sunstone's real power. It's not just about whether Vikings had the tool, but how they wielded it to stretch the boundaries of the possible. And in that light, Vinland isn't just a place on a map. It's a testament to what happens when human ingenuity stares down the unknown and refuses to blink. The mystery of Viking sunstones is far from solved. In fact, we may be on the brink of breakthroughs that could rewrite history. One tantalizing question lingers in labs worldwide. Could microscopic traces of calcite or cordierite still cling to Viking artifacts, invisible to the naked eye but detectable with modern technology? Archaeologists are now employing techniques like X-ray fluorescence and residue analysis on navigational tools, wooden compass fragments, ship rivets, even the inner surfaces of recovered drinking horns, searching for mineral signatures that might hint at sunstone contact. Imagine discovering a 9th century sextant with faint calcite dust trapped in its crevices, or a navigator's whetstone polished smooth from repeatedly sharpening a crystal's edge. These ghost imprints could be the smoking guns we've missed for centuries. Then there's the hunt for lost texts. Medieval European monasteries were notorious for repurposing older manuscripts, scraping off parchment to reuse it for religious works. Beneath the ink of countless prayer books could lie erased Norse navigation manuals or trader logs describing sunstone techniques. Recent advances in multispectral imaging have already uncovered hidden writings in palimpsests, layered manuscripts once thought blank. A single rediscovered sentence, like "the helmsman turned the sky stone until the twin lights burned even," could change everything. The potential is staggering. Private collections and cathedral archives remain largely unexamined, their vaults possibly holding fragments of Viking knowledge preserved by chance. Ocean archaeology offers another frontier. Less than 5% of known Viking shipwrecks have been excavated, their contents sealed in cold, oxygen-poor waters that preserve organic materials. A sunstone wouldn't survive as a whole crystal, but its mineral remnants might linger in the sediment near a navigator's station. The recent discovery of a navigator's toolkit on a wreck off Estonia, complete with a wooden protractor and whalebone tablets etched with star charts, proves such finds are possible. Underwater drones equipped with spectral scanners could one day detect calcite's unique chemical fingerprint amid the debris of a long-lost longship. Perhaps the most provocative avenue is biomolecular archaeology. Scientists are now analyzing dental calculus, the hardened plaque on Viking teeth, for traces of minerals ingested during a lifetime. Navigators who habitually tested sunstones by licking them to check for impurities, a common medieval practice, might have left behind microscopic crystal fragments in their mouths. It's a long shot, but so was extracting DNA from a 4,000-year-old chewing gum until someone did it. The future of sunstone research isn't just about finding objects, it's about rethinking how we look. Portable polarization detectors could scan museum collections for mislabeled minerals, while AI might soon cross-reference saga passages with global weather patterns to identify voyages where sunstones were most likely used. Every unanswered question is a thread waiting to be pulled, from the chemical composition of Viking-era Icelandic spar to the untranslated marginalia in Byzantine trade ledgers. What we need isn't just luck, but a willingness to see the past not as a static museum exhibit, but as a living puzzle, one where the next clue could be hiding in plain sight, waiting for the right light to reveal it. Picture yourself standing on the deck of a Viking longship, the horizon swallowed by a dense curtain of fog. The wind bites at your face, and the only sound is the creak of wood and the slap of waves against the hull. Your crew watches you, their fate in your hands. Now reach into your pouch and pull out your secret weapon, a piece of Icelandic calcite, its surface cloudy but humming with hidden potential. First, cradle the crystal in your palm, letting it warm to your touch. Hold it up to the gray sky, rotating it slowly. At first, nothing, then wait a flicker. The calcite's magic isn't in dramatic beams of light, but in the faint doubling of the world through its lens. As you turn the stone, you'll notice the split images of the fog shifting in intensity. The key is finding the angle where both beams match in brightness, their twin glows merging into equilibrium. That's your clue. The line between those beams points straight to the sun's hidden position, even if your eyes see nothing but gloom. Now cross-reference with your sun compass a wooden disc notched with markings for latitude. Align the compass's shadow board with the bearing your sunstone revealed. If the shadow falls between the third and fourth notch, you're likely near Greenland's waters, closer to the fifth, and Iceland might be within reach. But here's where Viking intuition kicks in. The stone gives you a direction, not a map. You'll need to factor in the ocean's whispers, the way the current tugs at the hull. The sudden appearance of driftwood bobbing in the waves' land is near when the wood bears fresh carvings of lichen. Make a mistake and the consequences are dire. Misjudge the angle by even 10 degrees, and over days of sailing, that error compounds into miles off course. That's why Viking navigators didn't rely on a single reading. They'd check and recheck, comparing the stone's guidance with the flight patterns of gannet's birds that never stray more than 50 miles from shore. At night, if the fog lifted, they'd verify their course against the North Star's fixed glow. The sunstone wasn't a standalone miracle, it was the anchor in a web of survival tactics. Now imagine the storm worsens, rain lashes the deck, and the calcite grows slippery in your grip. Here's the true test. Can you trust the stone when your instincts scream to retreat? Modern experiments show that even in downpours, polarized light persists, but interpreting it requires nerves of steel. The sagas tell of navigators who hesitated, second-guessed, and paid with their lives. Those who succeeded, they moved with the quiet certainty of those who'd done this 1,000 times before. So, could you use a sunstone? The answer is yes, but not without training. Today's sailors who have tried it describe a steep learning curve, hours of practice to distinguish the crystal's subtle cues from wishful thinking. Yet those who persist find something eerie happening. Over time, the stone becomes an extension of their senses, like a musician learning to hear the undertones in a chord. The Vikings didn't just possess a tool, they cultivated a relationship with it, honed through generations of trial and error. What's startling is how visceral the experience remains across centuries. Hold a calcite crystal up to a cloudy sky today, and the same physics that guided Leif Erikson still hums within it. The real challenge isn't the technology, it's the humility to admit how much we've forgotten. In an age of satellites and sonar, we've lost the art of listening to light itself. But the stones remember, and somewhere in their milky depths, the old navigator's wisdom still waits, ready to guide anyone bold enough to look. The Viking Sunstone remains one of history's most tantalizing puzzles, a fusion of myth and science, practicality and legend. Whether these crystals were precise navigational tools or symbolic objects imbued with ritual significance, their legacy endures as a testament to Viking ingenuity. These weren't just sailors, they were innovators who turned raw nature into a roadmap, who stared into storms and saw not chaos but hidden patterns. The absence of a sunstone in the archaeological record doesn't disprove their existence, it magnifies the mystery. How many other secrets did the Vikings carry to their graves? How much of their brilliance was lost to time, leaving only echoes in sagas and whispers in the wind? What makes the sunstone so captivating isn't just the question of whether it worked, but what its potential existence reveals about human creativity. The Vikings didn't wait for technology to conquer their world. They forged it from ice and light, from instinct and observation. In an era when most of Europe clung to coastlines, they crossed oceans with tools we're still struggling to fully understand. That audacity, to trust a sliver of crystal in a tempest, to bet your life on the invisible, is the heart of their story. So where does that leave us? The debate rages on, and that's the beauty of it. History isn't a locked vault of answers. It's a conversation, a clash of theories and discoveries that keeps the past alive. Maybe you believe sunstones were real, their science hidden in plain sight. Maybe you think they're poetic metaphors lost in translation. Or perhaps there's a third possibility, something we haven't even considered yet. That's the thrill of the hunt. Now it's your turn. What's your theory? Drop your thoughts in the comments below. Did Vikings wield sunstones as navigational marvels, or is the truth even more fascinating? And if you love diving into history's unsolved riddles, don't forget to subscribe. From ancient artifacts to cryptic manuscripts, we're just getting started. The past is full of stories waiting to be uncovered, and the next one might just rewrite what we thought we knew.